Let me just talk about what uncertainty is, okay? There's two types of uncertainty. So if you've got 5 plus or minus 2, what that means is that we really don't know. We think that maybe it's somewhere between 3 and 7. The actual number is somewhere between. We think it's 5, but it could be minus 5 minus 2, or it could be 5 plus 2, right? So it's somewhere in this range. That's physically what it means, okay? Now, the absolute uncertainty, absolute just means it's a number, okay? For this guy is 2. If we talk about fractional uncertainty, okay, the fractional uncertainty would be the uncertainty as a fraction. What fraction of the original number is the uncertainty? So in this case, it's 2/5, right? That's our fractional, which is 0.4, right? We could say it that way. We could also say that it's 40%, right? 40% literally means 40 divided by 100, which is 0.4, okay? In case you didn't catch that in math class. So that's the types of uncertainty. The question, the other valid question that you might have is, how did we get this 2? Where did this guy come from, right? So this thing could come from, if we did, so let's say we did multiple trials. Let's suppose we measured this and we got a 3, and then the next time we measured it, we got a 7, and then we got a 4 and a 6 and a 5, right? We could average all those and say, well, the average is 5, right? The average of those guys. That's supposed to be a straight line. And the average of that is 5, right? Okay, and then we would say that it's the range plus or minus the range of many things, right? Over 2. Well, the range of this whole number here is 7 minus 3 is 2, right? So it's 7 minus 3 over 2, like that, right? And then that's, of course, 7 minus 3 is 4. 4 divided by 2 would be its plus or minus 2. So that's one way to do it, right? If you have multiple readings of something, average them, and then its range over 2. It could be if you've got, let's say, a meter stick. Let's suppose you've got a meter stick and it's divided into, so it's divided into 10 equal parts, right? If this is a centimeter, then the smallest division, right, is 1 millimeter, right? So the smallest division is 0.1 centimeters, or 1 millimeter, right? Then the uncertainty would be plus or minus 0.05 centimeters. Okay, it'd be half that smallest division. So the rule for that, if you're reading a thing, is that it's half the smallest division on a meter stick. This is also true, I think, for like analog meters, where you've got a needle and a scale behind it, right? It's half that smallest division. I think, let's suppose you had an ammeter and it was 3.27 amps, okay? You would take, IB wants us to take this is the last digit, okay? So you could also take the last digit of a digital display, right? So it's plus or minus, this guy would be plus or minus 0.01, because the hundredths place is the last digit, okay? So these are the rules, and what we're going to do is we're going to do these guys as we come to them in our labs, right? For the air rocket lab, you'll have a range, and you'll go high minus low divided by 2, right? Eventually, we're going to do smallest division, and we'll do this, I think next year we'll do something with an ammeter. So anyway, that's the scoop on that.